No, thank you. That's the word. Wow. So I got the mad cow, the brain. So I had left you with some dilution homework several days ago. I promise. I'm not making it up. Okay. I promise. I promise I gave it to you. I want to go through a couple practice questions like this. Then we go on to today's lesson, and then we're just going to take some time and practice. Yeah.
I don't think you would hear that thing. You went here for the full lesson, which is probably means you didn't get this.
Probably right. That's okay.
Because there's the thing with the dilution.
That's okay. You can do it now.
Can I have a sheet then?
You can find it up on the OneNote. It's on the. Which is to say, I don't have it. I don't have it in front of me.
Also, can I just? No, that's not. Can I get you to initial the page?
Yep. Not yes, for sure. Remind me, but not. I don't have I have to look at first, and I haven't had a chance to look at yet, but I will. Okay. So, and again, like, don't worry about even writing it down. Just try the question on line paper. You don't even have to write the question down. You can just say dilutions worksheet 1, and then when you do print it off, you'll have it. But this first one, if I add 25 milliliters of water to 125 mils, as soon as you see that, what do we know we're doing? If I'm adding water to a solution, I'm diluting, right? I'm changing the concentration, and I'm changing the concentration not by adding more stuff, right? Not by adding more, what do we call the thing we're dissolving? The solute, yeah, not by adding more solute, but by changing the volume. And when we deal with dilutions, what formula can I use? What formula do we use to do dilutions? Yes, ma'am.
V1 times V1.
That's a highlighter. Sorry, you're doing great. Me, not so much. C1 times V1, yeah, equals? Very good, thanks. Sorry about that. Okay, and maybe you remember where we developed that, where it comes from, but we can say the initial concentration times the initial volume must equal the final concentration times the final volume. So now we just have to figure out what all these numbers are. So how much of this stuff do I start with? What's my initial volume in this question? I'm adding 25 to 125, so I'm going to have 150. Am I going to have 150 at the beginning or at the end? Good, so that would be what? So volume 2 is 150. I agree. What would volume 1 be then? How much? Very good. What else do I know? What else do I know? So my concentration 1 is 0.15 molar. Good. By the way, I'm not putting it here, but what does molar stand for again? Moles per liter. Good. So that's where I got that. That's where I got that. And this, remember, is that 125 mils that we started with, plus the 25 mils we added, right? What then am I obviously looking to find? C2, yeah. Is this easier if I turn that off? Is that better? Great, so I'm obviously looking to solve for C2 here. So what should I do next? What would your next step be? Put the numbers in. Great. So what am I going to get? Very good. So 0.15 molar times 125 milliliters is going to be equal to? Very good. So C2 I still don't know. And then that's times 150 milliliters. Now, interestingly, some of you noticed this the other day. Some of you didn't. Do I need to convert these milliliters to liters? Why not? When I manipulate this, what's going to happen to those units? They're going to cancel. As long as my two volumes are in the same unit, they don't need to be in the same unit as my concentration. It doesn't matter. I could have 3 gallons and 5 gallons here. That would be okay. So what am I going to do to solve this now for C2? Very good. I'm going to divide this side by 150 milliliters to get C2 by itself. And what I do to one side of an equation, I must do to the other, exactly. And let's note milliliters will cancel with milliliters. What unit will I be left with? Yeah, moles per liter. And what's the actual number work out to? It's going to be on the order of what? 0.1213? Is it 125? And of course, how many sig figs should I have? So I should say C2 equals, what's the rule with 5s?
1, 2.
Very good. Yeah, I mean, normally you'd be totally right, but remember that with 5s exactly, we have this kind of somewhat arbitrary rule that we always go to the even number. Good. How's that feel? I'm going to come back to some more practice with this stuff later on, after today's lesson. Is that okay? I just want to keep these fresh in our minds. Make sure you go through and do some of these dilution practices. I might even put a second page of dilution practice up on the OneNote as well that you can go grab if you want, okay? I'll keep lots of samples on there because it's just good practice to get. I'm hoping, let me ask you, and you can be honest, like if the answer is no, not one bit, I'd like to know that. But did you find that actually physically having to do this stuff helped you get a sense of how and why these equations work?
Yeah.
Or did you find there to be kind of no connection there?
Well, I wasn't
Didn't help you, yeah. You didn't find that it jogged some kind of connection.
I always thought like this one and the one that we did before was the same thing, just a different way to do it.
I see.
So it was good to see that.
So it's good to see that they're kind of two distinctly separate, different processes. That's good to know. Yes, those should all be capital, and I'm sorry, I'm not always very diligent about making my capital M's look angular. Is that better? Yeah, or even better than McDonald's, if you make it look like the Motorola logo, you know, then it's like distinctly capital. Maybe I'll try to do that. I'll try to be mindful with a capital M. You're welcome. All right, so today we are going to do the trickiest thing we've done so far in this course. In fact, it's the trickiest thing you will do in this course. And I'm hoping you're going to see that you are well equipped for it, and as long as we go slowly and carefully, it's all okay. There's no need to panic. There's no need to worry. We can do this. Right?
I'm always in a constant state.
Are you in a constant state of panic?
24/7,
no,
constantly.
I feel that.
Constantly panicking.
So would it be fair to say you were both panicking and apathetic all at once?
Yes.
Oh, that's good. Oh, sorry. I'm not trying
Go
to,
to sleep.
I'm not trying to throw things at you. All right. So today, today I didn't actually put the note in. I just thought about putting the note in. Look at me.
I guess this was meant to be later.
Sorry?
So I guess we're a bit ahead of schedule.
In what sense?
Now that we have all studied chemistry, all Christmas break. That's very complicated.
Oh, did I not change that? Look at you guys. So you are ahead of the last time I taught this. Isn't that funny? Now, in the interest of full disclosure, the last time I taught this, it was a fiasco. But more on that later. The last time I taught this, I had a triple split. So I was teaching grade 11 university chemistry, grade 12 university chemistry, and grade 12 college chemistry all at the same time every day. So it was insane. It was the hardest thing I've ever done. I went home every night. You want to talk about feeling in a constant state of panic? I went home every night like hyperventilating. So on any given day, the grade 12U kids were watching a video of me in a separate classroom while I was working with the 11s one-on-one. And then the next day we'd switch. And the grade 11s were watching a video of me and I was working with the 12s one-on-one. And it was disastrous. But then the worst thing about it was, before that in the morning, I had a pure grade 11 UChem class, not split. And after that, I had a pure grade 12 UChem class. So like these poor kids who were stuck in the split had friends who were in not split classes. I don't even like to think about it. don't know if you can see me like starting to shake up here, but it was yeah, it was scary. Yes, of course. Anyway, so you guys, it's just like a breath of fresh air teaching it this way. I thought last time I was going to end up in like some sort of institution. I was going to make a joke about this being an institution, this room, and I thought that was rude, and I'm not going to make it. But then I mentioned that I was going to make the joke, which, yeah, I should have just said nothing. But anyway, it was going to be a Zach Brown joke, and then I thought it was mean-spirited, so I left it alone. Well, no, it was. It was. That's where it was going, and then never mind. Just I apologize. Okay.
Whatever you say is most likely true.
No, maybe. So where this has obviously all been leading is to do stoichiometry with solutions, right? Like obviously where this has been leading is to go from concentration to moles to grams of something, right? So a 3-step kind of stoichiometry question, which is something we haven't done before. So I want to look at the first example, which is finding the mass of a product given the concentration of a reactant. All right? So in this case, we're going to try to make iron by reacting sodium metal with iron 2 oxide. Now, the first thing I want you to do, you definitely know how to do, which is just make this reaction. We're reacting sodium metal with iron 2 oxide. So give me a balanced chemical equation here for the reaction between sodium metal and iron 2 oxide. It's been a week since we've done reactions, so you might have to like shake off a bit of rust, no pun intended. You know, a little bit of iron 2 oxide. Sodium takes what charge? What group is it in?
So 1+.
1+, very good. Sorry, let's make sure we get this down so we have it in our notes. I can help you here. So what are we starting with? We're starting with sodium metal. So what's our symbol for sodium? You have periodic table? You have periodic table.
I do.
All right, let's get that thing out. Let's be a team here. Now, when it's on its own, does sodium have a charge? We're going to have to use that charge eventually, but when it's on its own, it's just sodium. It's just Na. Oh, I see. You're just getting set up. So I'm going to shut up and leave you alone. You're doing great.
Yeah, but I do.
You are good, you.
Like she just comes over and starts like ranting about it. She's so like flustered and all just like and she just like
Okay.
It's called the word war, but you don't know which one it is. So it's a guess and choose.
That's great.
I just go with the
The only thing I'd like you to tell me is this will be what state?
I'm looking at that right now. Or should I?
Oh, it's a solution. We know it's a solution, right? So what state is it? Aqueous. Good.
Both of them are safe?
And then
You gotta look up the other one?
sodium oxide will be aqueous.
solid and gas.
No problem. You just to know if it's aqueous or not, you just have to look it up on the solubility table. I'll tell you right now, here everything dissolves except the solid metals, which are solid. And that's it. It is confusing, but like it's one of those things where it's confusing when you do it on paper, and in a lab it'd be obvious to you because the ones that are just see-through in a liquid, you'd be like, oh, that's aqueous, and the ones that are solid to the bottom. Well, for sure. That's why we try to do as many labs as we can, because it really is, it helps you cement what you know, right? All right, who can get me started? Am I rushing you? Am I going too quick? Tell me if I am. I've been told that before. So what are we starting with in this reaction? Yeah, Ruby. Oh, good. So that is FeO is what compound?
Iron oxide.
Very good. And of course, the way we know it's FeO is iron takes a 2+ charge because it's iron 2, and oxygen always takes a 2- charge. Great. And what state of matter is that?
Aqueous.
Aqueous, because it's a solution, right? It's dissolved in water. And what are we reacting that with?
Solid sodium.
Solid sodium. How am I going to write that?
And A.
Yeah, so solid sodium. Comme ça? Oui. And what kind of reaction is this going to be? Single displacement, which means that what? Good. So we're going to end up with what by itself? Iron. Don't worry, I planned one that works. Though you're totally right. Like you're 100% correct that we should check to see if it's more reactive. In this case, I picked an example that I promise does work. But you are spot on because you'd save yourself a lot of work if the answer is nothing happens. And what will the other compound be? Good. And how do you know that?
Because has a 1+ charge and oxygen has a 2-.
Good. And so for that to be charge balanced, we have to double up on this guy, right? So we end up with Na2O. And you can look it up if you want. I'm confident that is soluble, so that'll be aqueous. And to balance this, I have to put 2 in front of the solid sodium. Okay, is everyone comfortable with that? That feels good? Tell me if it doesn't. Doesn't. Wow. Doesn't. Tell me if it doesn't. God, aren't I? Okay. So now, in this case, I've told you 2 things I'm starting with. What are we starting with? Or 2 things about what we're starting with, I suppose I should say. Yeah.
Iron oxide.
Okay, and how much of it?
0.5 moles per liter.
Good, so there's 0.5 moles in every liter. And do I have a liter?
No.
No, how much do I have? 100 milliliters. Good. Does that make sense? So I am starting with 100 milliliters of this stuff. My advice for these questions is you're almost always best off to draw a little map on this thing. Does that make sense? And here's what I think. This could be something you put on the side, but the central unit, what we always end up going to work with in this is what? Pretty much every question, no matter what we start with, at some point we say you need to figure out how many moles you have. Does that make sense? Because moles allow us to look at a balanced chemical equation and say, okay, well, if I know how many moles of this thing I have, I get excited. If I know, I'm so athletic. That went like a whole 2 feet. I'd be worried it were broken if that hadn't been the most pathetic throw in the history of mankind. Anyway, if I know how many moles of one thing I can figure out how many moles of something else I have. So what letter do we use to symbolize how many moles? N for number of moles. And we measure that in moles, right? Now, what are the different ways I can get to and from number of moles? Yeah, it's just a good thing to remind ourselves. I would say one of them is obvious, mass, right? Which we typically measure in grams. And the nice thing with that is this. If I want to go from mass to number of moles, I can just multiply by how many moles or how many grams are in a mole, right? And if I want to go the other way, I actually use the same number. I just flip it, right? So on top would go grams, and on the bottom would go 1 mole, right? Does that make sense? So when we're doing dimensional analysis, I can always get from my mass to my number of moles just using that calculation. I know we can talk about number of particles, but I'm actually going to leave that alone because for the purpose of actual chemistry, that's not something we really talk about, right? Remember way back at the beginning of last unit, we said if I have 3.15 times 10 to the 21 carbon atoms, but in reality, is that ever something I'm going to give you? No, because nobody's going to sit there and count out carbon atoms. So it's not really a useful, it's not a useful thing. But what is useful is also knowing about concentration. Does that make sense? Or sorry, from volume. And we measure volume in liters typically, right? And here, too, remember that if we know the volume of something we have, we can figure out how many moles if we know its concentration, right? So if I want to go from liters to moles, I would multiply by a fraction. On the bottom, I would put liters, and on the top, I would put moles. And where does that actual number come from? That's going to be the concentration, right? Does that make sense? Like this number here is just concentration. In the same way that this number here was just molar mass, right? If I know the molar mass, I can go from mass to number of moles. If I know the concentration, I can go from volume to number of moles. Does that make sense? And obviously I could go the other way as well, right? If I know the number of moles and I want volume, I would multiply by a fraction, but I would put liters on top and moles on the bottom. And again, I'm just using the concentration. Though in this case, I flipped it. And then, of course, once I know the moles of one thing, I can always figure out the number of moles of something else. Yes? No problem. So, sorry for the detour, but does that kind of sketch of how we can map things out make a bit of sense? Again, some people find visual aids like this completely useless. Some people find them quite useful. I like to draw a map. Does that make sense? With that in mind, can we take a look at this question? We are going to start out with what? Well, we're going to start out with the concentration of what? What did I tell you we had? Yeah, sorry, I'm going to say we, even more to the point, we know the volume, right? So we know the volume, which is 100 milliliters of iron 2 oxide, right? And do I want to know the volume of iron oxide I have? I mean, eventually, what do I want to know? Over here, when I'm done, I want to know what from this question? The mass of? The mass, how many grams of? Nope, what's to ask? Like at the very end of the question. How many grams of iron? I want to know how many grams of iron. Can I get directly from volume of iron oxide to grams of iron? No. But if I know the volume of iron oxide, as long as I know its concentration, what can I figure out? Number of moles of iron oxide, right? What is the concentration, by the way? Yeah.
0.5 moles per liter.
0.5 moles per liter. Good. Now, if I know how many moles of iron oxide I have, what can I figure out next? Yeah, I can figure out how many moles of iron. And to do that, I'm going to look at the equation, right? So I'm going to look at the balanced chemical equation. And if I know how many moles of iron I have, then it's easy to figure out the mass of iron I have, how many grams. Does that make sense? Because to go from number of moles to mass, what do I need to know? What do I need to know? Molar mass, good. Now again, I do not require you to draw a diagram like this. You don't have to. You may find it helpful. You may find it counterproductive. But for me, if I kind of sketch out what I'd like to do, then it really, really, really helps me just sit down and do the question. Does anyone have any questions about that? And again, there's a lot of different ways to start a question like this. But to me, if you look at this graph, I always think, what can I go from? I can go from volume to number of moles to mass. Or volume of number of moles to number of moles of something else to mass. Does that make sense? So I find having this chart of like, because the question here is, what should I start with? Should I start with 0.5 molar or should I start with 100 milliliters as my given? Right? Well, to me, I always start with the volume as a given. It's not the only way to do it, but it's how I do it. So with that in mind, what is our volume? 100 milliliters. No, so what should I do? Convert to liters. To do that, what do I have to do? 1 liter is 1,000 milliliters. And again, if you're super keen and you looked at that and said, can I just start with 0.1 liters? Yeah, of course you can. Now, from here, I don't want to talk about the volume of iron oxide I have, right? I want to talk about how many moles of iron oxide I have. So what do I want to do? I've canceled milliliters. If I stop now, I'd know how many liters of this stuff I have. What should I do next? I want to know how many moles. So what am I going to put in this fraction? Just units first.
You're going to put liters on the top.
Like that? If I put it on the top, I'd have...
On the bottom.
Good,
Sorry,
but no problem, because if I put it on the top, I would have liters times liters, which would be liters squared.
That you crossed off the little, like the element.
Oh, I see, yeah. No, that's milliliters. So I'm going to put liters on the bottom, so it will cancel. And what do I want on the top? Moles of FeO. Good. And here we have to ask, do I know how many moles are in a liter of iron oxide? Yeah, in this question, how many moles are in every liter? 0.5. And that's in how many liters? 1. Right? Concentration is always per 1 liter. Just like molar mass was always per 1 mole, concentration is always per 1 liter. Does that make sense? Again, you could tell me if it doesn't. Okay, what cancels here? If I stopped calculating now, what would I know? I'd know how many moles of... Good. Can I mention something, by the way? Sometimes people like to stop in the middle of the dimensional analysis to catch their breath. I recommend going all the way through. But if you're the type of person who likes to go, I don't want to do 7 fractions in a row because I get confused, you could actually stop here and calculate. And you could just pause and say, okay, now I know how many moles of iron oxide I have. And kind of restart the question from there. Does that make sense? We're going to keep going. But some people find it helpful to chunk it up. And if that's you, if you say to yourself, I really feel like these questions, the fraction gets too long and I get lost, talk to me. And I can talk to you about doing it in smaller chunks so it's less overwhelming. Does that make sense? I'm still going to teach it the same way. But if you feel like it just gets too long and you just get lost, talk to me. What should I do next? What will my next step be? Alondra, what do you think?
How many moles of iron oxide there are for every mole of iron?
I love it. So when we're done with that, we'll know how many moles of iron we have. And what am I going to put in this next fraction then? No numbers yet, just units. So moles of FeO on the bottom, iron oxide on the bottom. And on the top? Moles of iron. Very good. Now, where am I going to get numbers for this? The balanced chemical equation. And let's look at the balanced chemical equation. What do we have? Yeah, FeO has 1, and iron has 1. So this is nice, simple stoichiometry, a 1-to-1 ratio. Now, what cancels here? Yeah, moles specifically of iron oxide with moles of iron oxide. If I stopped calculating now, what would I know? I'd know how many moles of iron are going to get made. And the last thing then, the question doesn't ask me how many moles of iron I'll get. The question asks me how many grams of iron. So what am I going to have to multiply by? Moles of what on the bottom? Good. And on the top? Very good. All right, and take a minute and find that and do the calculation. And use sig figs, please. I assume that it's the Eastdale Equestrian show today. I believe dressage is happening. Which reminds me, our dressage contest will be next week. I don't know about you, but I've been training hard. Rafalka and I are ready to really put on a show. Right? Does it? Oh, I failed. That's my voice. I wish I could. I don't know when I was a kid, but I wrote wrestling. I remember, yes. That seems totally reasonable, and the process is really good. I won't know until I do the math, but that looks great. Did I give you 5 more? Yeah, so 1 something. And 100 mils. Right? Yeah, so you do have the smallest sleeves. They're very. Nice. How's that feel? Not so bad, right? It's long. It's just yeah, that's right. It's just what I said. That is the hardest thing you've done. It's probably the trickiest thing most of you have had to do in high school so far. Yeah, if you take the 3U math, there's some stuff in the the trig identity proofs are pretty tricky. Depending on the kind of thing. To me, like the algebra of parabola stuff comes quickly to me, but you're either that kind of kid or you're not.
I'm really good with algebra, like trying to figure out
That's true. Your algebra is fine. With you, it is just the more interpretive questions that you do right away. Because yeah, that's true. Your algebra is actually really strong.
I've always
Yeah.
I really like those angles. Where you get 10 angles and you do one, and you're like, oh, I can do this.
I love that too. That's in grade 10 a lot, right? Or 9. Is that in 9?
It's in 10. Well, we did it in 10.
The 2D. Yeah. Yeah, I've never taught the 2D, but I really like the looks of the 2D. Like the grade 10 academic now.
Like our house.
Yeah. There's a lot of fun stuff in there. Because you do all the trig, right? Like sine law, cosine law, cosine law, SOHCAHTOA. I love right angle trig. I love non-right angle trig. And then you do linear systems and stuff again, which is kind of boring, but whatever, it's fine. You do quadratics, which I like. And then you do all of the geometry stuff and finding the midsection of the lines and stuff like that. I like that. Yeah. Okay, so let me ask you guys, what numbers have I failed to put in here? What numbers need to go in? Do we know how many grams are in a mole of iron? Yeah, what did you get? Ireland. How do I read that? Is that like a... Maybe there's an N on the end. Mreh.
That's more like wrong.
That's true. How does one spell mreh?
Maybe it's like 80.
Okay. Anyway, I'm sorry. What number goes in there? 55.
0.847.
Cool. And that's in 1 mole. And when we work this out, what do we get? Whatever. It's not going to matter. It's not going to matter because we have 1 sig fig. So if we had lots of sig figs, we'd have to stress about it. Different periodic tables do have slightly different numbers. And this works out to 3. 3 what? 3 little kittens sitting in mittens. What do we have? 3 grams of iron. Okay, not little kittens. Okay. I wish to. Okay.
Bring in Milo. I want Milo. You want my fluffy.
I want to try this next one too. And we may only get through the 2 examples in today's class, but I want you guys to see if you can self-direct on this one a bit. See if you can give it a try. Obviously, we'll take it up together, but I want you to start this one. Go through, talk to the people around you, communicate, but we're going to try to figure out what concentration of copper 2 sulfate solution is required to react with excess iron to produce 1.2 grams of solid copper in 1 liter of solution. Now, the one thing I'll tell you is this. You're going to have to find a balanced chemical equation. But when you go to start, remember that you can go from mass to moles and so on and so forth. Your final answer for this is going to be a concentration, which is going to be in moles per liter, right? Now, the nice thing is this. You have one of those 2 numbers already. So in moles per liter, you need to know how many moles you have and how many liters you have. Do we know either of those things yet? What do we know? We know how many liters we have. So all you need to find to answer this question is how many moles. So really what you're trying to find is moles of copper 2 sulfate. Does that make sense?
You just say excess iron. You don't know if it's higher to area.
When you make the compound, because obviously the iron on its own is just iron, but when iron makes the compound, let's all use iron 2. Yeah, sulfate. Good. So yeah, when we do this question, let's all do iron 2 sulfate. So we all get the same answer. Does that make sense? Okay, so get going on that. Do your best. Don't be shy. And if you're not sure where to start, ask that. Yeah, that's the reason anything when it's on film, right? But when we make the compound,
You guys can do whatever you want. I just want that to be yellow. If you guys have a better combination, if you want and if you guys have anything else you want, go ahead. Do something. Don't be afraid. Whip glitter at the board.
I'm not looking glitter around the class.
No, not around the class, at the board. Make it perfect.
the different ways. The thing you used to do.
You're pretty weird.
Where you don't go and this workers go until you pay for it.
You're pretty weird.
$200 down on the first one. This one was $80 down. You went to the first one. Every week I get my paycheck and I go. I was every week I collect I would do too. But anyway, so I still feel it. So mad. And I do, I'm going to run, you have chores. This thing, the whole beat out of Japanese.
Hello, on the other hand, beats me and probably would take a nap.
Phonics put in it.
finished it on it was like project. I've done it.
I don't know what I would do.
Store it. And a big barn, and I used to store stuff there. You know, and my guitar that I spent a decade working on sold. Not only that, listen to it. Oh, and I'd probably dropped $700 into this thing, and like new electronics and I was inconsolable.
What?
It was my fault. Like, I just straight up put it in the wrong place. Yeah. Oh, I can't even do that now without like stuff in the wrong.
Who sold it for $30?
I bought it when I was like 13, and I fixed it up, and I accidentally sold it at like age 26, so 13 years later. But I had just, this thing had been like my hot rod, like, I had just like so much time on it. And I learned all kinds of stuff, right? Like I learned about rewrapping things, and I learned about
I would wire
rewiring
like
electronics.
like people are with their verses, I would carry my guitar.
Yeah. And I always look for it. Like I always, every week I go on GG and then,
Still.
There's a make called Westone, and I collect them. I have 5 Westones, but this was the first one. And it was a Westone Prestige 250, which was a low production run, and you don't see them very often. So every once in a while one goes for sale. And the thing is, I bought mine for just like $250, and now they go for about $1,400-1,500 on average now. And I just can't bring myself to pay $1,500 for one, and then like have it shipped from like the UK, which is the only place you ever seem to see it for sale. So I just have left it around. One day I'll see one and snag it. And then I almost bought a Prestige 150 one year, and I was like, it's just junkier, and it's an addiction. I'm not going to spend $1,100.
Okay, we go backwards. Okay, actually, we go backwards. We
Yes, ma'am.
back off.
Is this iron? Wait, so we start solid.
Yeah, when you're going to make the solution, use iron.
I have guitars and not single bass. I need.
I have a big which I like a,
I'm not looking for a good bass because I think it just fix the tone.
I have a Spider Jazz, and it's fine. No, not jazz bass, and jazz bass. And it's fine.
Well, good drums and we
That's just.
I know.
I got them. They didn't.
Well, that's okay.
They have little fret bumps.
It's properly
Has to
tuned.
go with the
Yes.
Yeah, I think he does it.
I don't know what I have to say.
Like
Because he plays that.
You just have I don't know what that is.
Whereas like
It's what is
classical
the
jazz,
bass song?
Well, they also have long. There's different. Because the normal size for these guys is like.
And from last night.
But it's just like, because the classical bass, like every other classical, is tuned in fifths, right?
Yeah.
Whereas guitars tuned in fourths, fifths, and it's so I would say this. We're gonna use the volume right at the end.
Why would I be staring at your stomach?
And figure out the concentration of this and how many points. Right?
I would like to watch
Before
your
that, does the volume
stomach.
matter?
It's funny because
We're
my
not gonna use that volume until right at
nobody
the
would
end.
be watching your
I would
stomach.
say-
I know, but that's
I
what
would
they
go from
would
that.
do.
So I need my
Rolls of one thing.
cable for it.
And then they did, they fully
The other's
think you have a
better.
baby in there.
And then once I know that.
That's
now I know how many
no, it's
moles.
just what your
Then
stomach does.
moles per liter, right? Divided by the
This
liter.
is the way that's gonna be in the ground.
So even though this question says what is the concentration, really what you're figuring out is how many moles. And then next step, you say, okay, now I know how many moles concentration. Does that make sense?
You are weird.
So
You're weird. You're weird. Why so? You're talking about people looking at your belly.
I don't understand that.
I think you started great. So what I would say for this one, I would say we want to eventually get, yeah, we want to get the concentration of this, but really concentration is just moles per liter, and we don't need to find how many liters. We already know. It's 1 liter. So really, all you need is moles of this. So this is actually an easy one because you've got grams of copper, from grams of copper, you're going to figure out how many good. And then from moles of copper, you're going to figure out how many moles of. Yeah, and then once you've got that, you just divide it by how many liters, and you'll have moles per liter. Does that make sense?
So do like one more.
But like these were
Oh, like,
Yeah. Yeah. We'll have to look that up. But my dear, we're still doing chemistry. Since your test is next Wednesday, do the questions, do the questions, do the questions.
Oh wait, I don't even need this stuff. I just automatically went to converting this from right?
Okay, so far I know the answer right now with this 1.2 grams. I highlighted that.
yeah, I don't know, I don't get it.
Here's what I would do. So, I would say, eventually you want to concentrate, right? The concentration is just how many moles divided by how many liters. You've
Oh,
already
I
got half
got this down.
So let's pretend we
That's
don't
why
need
I'm
to
confused.
find
I got
it.
this
There's
down.
no liters. All we need to find is.
I skipped the entire step.
So we need to everywhere moles. And now, we care about that, right?
I thought this was like
We're gonna have to use it as a set, right? When we know how many moles, then we're gonna be moles divided by liters. But for now, that volume doesn't matter, right? Which means, I've only actually given you one other piece of information, which is.
Because then you'll get like half less of.
Yes. And then, what's the next thing you want to figure out? And once you know how many moles of copper we have, what's the next thing is electrical units?
So, I was so glad.
Mr. Orlando.
Yes.
Here for a second, please.
Who's saying that? Oh, yes.
Okay, I think I'm on the right track, but I'm not quite sure.
I think you're doing great. And can I tell you what I would do? I would stop right here. Because when you stop right here, what are you going to know? Of?
So now.
Good. And then eventually you want to know the concentration of compounds, right? So I'd figure out how many moles of that I have. Then I'd go down to a new line.
Me, I was wrong.
Yeah, I would stop there. And then I'd say, okay, now I know that.
I'm
Now,
looking for the.
now concentrate. Yeah, and I would do that as a second thought. You could do it in the same line, but I would do it in a second thought. I'd say, okay, now I know how many moles of copper sulfate I have. Then I'd go down to a new line and say, okay, concentration's easy. It's always how much solute divided by how much solvent. Now I know how many moles of solute I have because I just found it. And the question told me how much solvent I had.
Yeah, where is that?
And then boom, we'll be done.
Okay.
Okay.
So
I was right.
1 mole of.
In other words, I was right an hour later.
Yeah. Yeah. Though this is not true. 1 mole copper does not weigh 1.2 grams. We have 1.2 grams of copper, but that's not 1 mole.
That'd be like 0.6 moles.
I have no idea. You have to figure that out. So you're going to start with that 1.2 grams of copper. Oh, yes, you do. You've done this a million times, so don't start panicking now. How do you figure out how many moles that is?
I don't know.
You do the mole amount.
Yeah, you're going to multiply it by
Okay, but then
moles,
does
right?
that mean do I do that then?
Close, but I'm not sure that's correct.
And then times it?
Yeah, of course. Yep, beautiful. That's great.
Close amount according to the result.
The mountain community that as their language. Like birds, they can transfer. It goes farther than speech. So like if they're at the top, they can talk to the bottom.
Where did you decide to put it?
This one, anyway.
So,
And find my greatest beautiful.
It's like
I thought it was like first came
it's
up.
really, really fast.
No, you need to know the concentration. No, because I have to walk in to get the
I'm missing
And then she score. You get.
You got it.
Guys, can I ask, how does my equation look?
Quite good.
Yep.
Is that okay?
Yeah.
All right, thank you. Carry on. Yes, Ruby. No. I just wanted to make sure we all have the same.
I got here.
Great. I would stop.
Oh.
I would stop.
Oh.
And because now when you're done that, you'll know how many moles of copper sulfate you have. Get that number.
Oh,
And then say, okay, that's right. Now concentration is how much solute, and you'll have that number then. Divide by how much solvent, and we know that's 1 liter. And then and I would do that.
So I take the number I get from this and divide it by 1.2.
Divide it by how many liters do you have?
Oh, liters?
Yeah.
Okay.
Right? Because
So I
that's
put the number over the liters.
that's right.
Okay.
Yes. Are you confused? Why? Okay, this one doesn't have to be dimensional analysis. You've got this number. That is what? 0.19 moles of copper sulfate. Now concentration is just moles divided by
Oh, so it's just that number.
just moles divided by liters.
liters.
And how many? And then this one, I think I made it really easy because how many liters did I give you? Just 1. Yeah, that's all. We'll find out. We will find out. Okay, guys. At the risk of rushing you, can we go through this together so we make sure we all see the solution together? Okay. So I'm going to draw a map of this again. And I'm going to say at the end, I want to know how many moles of copper sulfate I have, right? Divided by how many liters I have. That's going to be my end game. Which means before I can do that, I need to know how many moles of copper sulfate I have, right? Because I already know this, right? This is the nice thing. This number, already have. In this question, what is it? Yeah, it's 1 liter. So I'm halfway there. So I just need to figure out the top. So I need to know how many moles of CuSO4 I have. What am I starting with? I only start with 2 given pieces of information. What are the 2 given pieces of information I've told you? And 1 liter. Now I know where I'm going to use 1 liter. I'm going to use it right at the end, right? So that can't be what I start with. So what am I obviously starting with? Yeah, is that the mass of copper? Yeah, okay. So 1.2 grams of copper get made in this reaction, right? Now, if I can figure out, if I know how many grams of copper got made, what can I easily figure out? Yeah, I can figure out how many moles of copper must have been made, right? Because we know the molar mass, right? By the way, what is the molar mass? 63.5463. Cool. If I know how many moles of copper I have, what can I then easily figure out? Right? And how will I do that? Yeah, from the balanced chemical equation. I left myself too big a space there. Does that make sense? Cool. So let's do this. What am I starting with? I'm starting with 1.2 grams of copper. What should I do next? Cool. So we know 1 mole of copper weighs how much? 63.5463? If I stopped calculating now, what would I know? Whoa! I'd know how many moles of copper I have. But of course, I'm not interested in how many moles of copper I have, so what do I have to do next? Moles to moles. Specifically, what am I no longer interested in? Moles of copper, and instead I want to know how much how many moles of copper sulfate I began with. What is the mole ratio for those? 1 to 1. If I stop now, what do I know? I'd know how many moles of copper sulfate I have. Now, one way to approach this is just stop now. Just get this answer. Figure out how many moles you have. If we do that, what do we figure out? What do we get for this number? Has anyone done it? That doesn't matter. Unless you're taking the sine, the cosine, and the tangent, not going to matter. Are you planning on taking the sine, the cosine, and the tangent? No, you're cool then. You can do it. Yeah, that makes sense. Yeah, what do we get? Great, so let's just say 0.188 for now. Okay, and that is moles of CuSO4. And then, is that the final answer I'm looking for? No, because the final answer I want is the concentration, which is moles per liter. Now, what would I have to do with this number then? Just divide it by our volume, which in this case is how many? 1 liter. So as it happens in this question, the number doesn't change, right? And so our final answer will be what? Final answer. I will, I promise. Because I believe we only have 2, correct? In fact, no. What do I have? I have 1 sig fig. So my final answer here will be what? 0. moles per liter. Yes, Ruby.
I got a different answer.
Can I see?
I got 0.0188. Yeah, that's what I.
Oh, did we miss a 0? Did we? I missed a 0. Sorry about that, guys. I think it is my fault, but I appreciate your defending me. Mark just got better. Yes. Not 2.0, because that'd be 2 sig figs, but 2 times 10 to the negative 2 would be completely correct. Absolutely. Just remember only 1 sig fig. But yes, scientific notation would be great. Can I make a suggestion too? You can totally stop here and do it this way. I would probably do this. I would put another fraction here, and I'd say, okay, I've got moles of copper sulfate on the top. What do I want on the bottom? Liters. And so I'm going to put how many liters I have. How many liters do I have? 1. And then on the top, I'm just going to put a placeholder. Does that make sense? In other words, if you want to put this information here and do nothing, because I'm not trying to cancel anything here, right? Rather, I'm trying to put this into the bottom without changing the top. So to not change the top, the number 1 leaves the top alone. Does that make sense? You don't have to do it this way. You can stop, get this number, and divide, or you can keep going up here. You'll get the exact same answer. To me, I like just doing it in one calculation. I like knowing that I only have to use my calculator once and that I'm done. Does that make sense? And so this means I must have started with a 0.02 molar copper sulfate solution. Cool. I want to take a break from this because I want you to try the example 3 and 4 as homework, and we'll take them up tomorrow. Does that make sense? So what I'd like to do in the time that remains is 2 things. 1,